All right, so R3 notes. This is part 2, but again, we're simplifying radicals. We're just adding on a little bit more to it today. So looking at example 11, here we're multiplying two radicals together. So whenever we're multiplying two radicals and we have the same index, so it's the same radical. All right, so we can combine the two numbers under the radical together. So this is like saying the square root of 3 times 3. So we just put them under the same radical. And what is 3 times 3? 9. And what's the square root of 9? 3. Awesome. Any questions there? All right, 11, we're doing the same thing, but we have numbers out front. So the two numbers that are out front get multiplied together because I'm multiplying. So 5 times 2 would be 10. Those stay out front. The numbers on the inside go together. So this would be 7 times 7 on the inside. Do I actually have to multiply 7 times 7 together? What does it take to get out of the inside of a radical? A pair. So I have a pair of 7s. So what happens to the pair of 7s? It can go outside. So this would be 10 times 7. Do I have anything left inside the radical? Nope. So just 10 times 7, which would be 70. If we wanted to, we could multiply these together and make 7 times 7 the square root of 49. And then the square root of 49 we know is 7. So you'd get the same thing. We can do the same thing with dividing. So if I'm dividing two radicals, I can make them under one radical. So I have 50 divided by 2. All under the same radical. What's 50 divided by 2? 25. Do we know what the square root of 25 is? 5. Awesome. So our answer here would be 5. Just like in the last one, how we can combine the two radicals into one, we could also take one radical and break it up into 2. So for number 14, this is like saying the square root of 9 over the square root of 64. What's the square root of 9? 3. Perfect. And what's the square root of 64? 8. So this is 3 over 8. Right. Radicals that have the same index and radicand are considered like radicals and can be added and subtracted. So in number 15, these are like radicals because I have the same square root 3 and square root 3. So that means I can add them or subtract them because here I'm subtracting. So in subtracting, you just subtract the coefficients together. So what's 8 minus 6? 2. And then the radical stays the same. So our answer here is 2 square root 3. So we just add or subtract the coefficients together and the radical stays the same. So the radicals have to be the same in order to add or subtract. For number 16, they're not the same, but maybe we could simplify it to become the same thing. So looking at the first part, the square root of 24, can I break down 24? What are two factors of 24? 4 and 6. And what are two factors of 4? 2 and 2. And two factors of 6? 3 and 2. So this is what we did yesterday. How can I simplify this? What should I do next? Well, what's going to come to the outside? 2 comes to the outside because I have a pair of 2's. And 3 times 2 stays on the inside because those don't have a pair. And then I also started off with a negative 2 on the outside, so I just have to put that there too. So if I have more than one number on the outside, what do I do to those two numbers? Multiply, so this would be -4. And then if I have more than one number that stayed on the inside, what do I do to those two numbers? Multiply, so 3 times 2 would be 6. So this changed into -4 square root 6 minus 3 square root 6. Are these now like radicals? Yep, these are the same. So that means I can subtract. How do I subtract them? So I add or subtract the coefficient. So it's -4 minus 3. Awesome, -7. And then what would come next? Square root 6. Perfect. So the radical stays the same in your answer. Just like when we were adding variables too, it stays the same. You just add the coefficients, the rest of it stays the same. All right, let's look at 17. Again, these are different, so we can't add them right off the bat, but let's see if we can simplify and make them the same. All right, so what are 2 factors of 45? 5 and 9. 5 is prime, so we can't break it down. What are 2 factors of 9? 3 and 3. So what's going to come to the outside here? 3. And I already had a 3 on the outside. What stays on the inside? 5. So this simplifies into 9 square root 5. Now let's break down the other one. What are 2 factors of 36? 6 and 6. Do I need to keep breaking these down? No, because I have a pair, so I could just circle it here. So what's going to come to the outside? 6. And what do I do with the 7 that was already on the outside? Multiply. So what's 7 times 6? 42. Can I add these together? Nope. They do not have the same radical, so I can't add them, so this would be my answer. All right, the last part of this section is when we are dividing with a radical, square roots must be eliminated from the denominator. So this is the bottom of a fraction. And it's called rationalizing. So when the question says rationalize the fraction, that means we have to get that square root out from the denominator. So it has to be eliminated. Got to get rid of it from out of the denominator. So how we can do that is we take whatever that number is in the denominator of our fraction, so that square root, we want to get rid of that square root from the denominator. So I'm going to multiply the top and the bottom of my fraction by square root that number. So here it's square root 2. So whatever I multiply to the bottom of it, I also have to multiply to the top. Because I'm not changing the value here since I'm multiplying it by square root 2 over square root 2, which is technically just 1. So on the top, what's 5 times square root 2? 5 square root 2, awesome. And then on the bottom, what's square root 2 times square root 2? Just 2. Remember, this is like saying square root 4, which is 2. And that's our answer. Our whole goal here is to get that square root out of the denominator. Any questions here? All right, let's look at 19. What do you think I have to multiply here to rationalize? Square root 3. Whatever it is in our denominator, that's what we multiply. So I multiply the top and the bottom by square root 3. On the top, what is square root 2 times square root 3? Awesome. Square root 6. Since they both have a square root, we can combine them together under one radical. So square root 6, we just multiply the insides together. And then what's square root 3 times square root 3? 3. Perfect. And that's our answer. Can I simplify this? Square root 6 divided by 3? I cannot, because 3 is a whole number. If it was square root 6 divided by square root 3, then you could simplify. But 3 is a whole number, so we can't divide into that square root 6. So instead of multiplying the top and the bottom by square root 32, I can break this down. So what are 2 factors of 32? 4 and 8. What are 2 factors of 4? 2 and 2. And 2 factors of 8? 2 and 4. And then I can break down the 4 even more into 2 and 2. So what should I circle here? The 2 pairs of 2. So what's going to come to the outside? How many 2s? 2 of them. 2 comes to the outside. And what stays on the inside? 2. So what does the square root 32 simplify to? 4 square root 2. Awesome. Next step is we need to rationalize. So how do I get that square root 2 out from the denominator? What do I need to do? Multiply what? Just the bottom and the top. We multiply the top and the bottom by square root 2. So what do I get on the top? What's 7 square root 6 times square root 2? 7 square root 12. Perfect. And then on the bottom, what's 4 square root 2 times square root 2? 8. Perfect. This is like saying 4 times 2, because remember, square root 2 and square root 2 turn into the whole number 2. The 4 was already out front, so 4 times 2 would be 8. So we rationalized. That was the goal, but can this be simplified anymore? How? Can I break down square root 12? What are 2 factors of 12? 6 and 2, or 4 and 3. That would work too. What are 2 factors of 6? 2 and 3. What can I circle here? 2. The 2. So what's going to come to the outside? 2. And what stays on the inside? 3. And then I already had what on the outside? 7. So then what's the last step? Multiply the 7 and the 2. So this would be 14 square root 3 over 8. And we could simplify this even more because what number goes into both 14 and 8? 2. So I can divide them both by 2. Because they are both whole numbers, neither one is in the radical, I can simplify. If one was in the radical and one was out, you can't simplify it. But because they're both whole numbers outside the radical, we can divide them both by 2. So this would be 7 square root 3 over 4. Notice how the radical just stays the same. I'm only dividing the whole number and the whole number.